Hello and welcome. In this video, I'm going to be giving you a sneak preview of some of the content that I'll be covering next week at the Everything Procedural conference in Breda in the Netherlands. In case you don't know, the Everything Procedural conference happens every year. It's a week long and it's an opportunity to go and learn from some of the brightest minds in the games industry and learn about all things procedural with Houdini, but not just Houdini. And it's an amazing place to go and learn, get inspired. So I'm going to be there this year along with the rest of the Project Pegasus team. We created Project Pegasus for side effect software to demonstrate open world workflows using Houdini and Unreal Engine. And this year we're going to be continuing along in that vein. It's also an opportunity to go and learn from some other incredible people who are working for side effects on a new project called Project Grot. So there's some incredible artists working on that project as well. So absolutely amazing. If you can't be there in person, I definitely recommend checking out the talks online. The part of the workflow that I'm going to be sharing with you today is actually really exciting to me personally. It's something that I've wanted to exist inside of Unreal for a long time. And I'm sure that people who are familiar with trying to create tooling that involves Unreal Engine and Houdini, there are going to be some maybe questions or challenges in that workflow that you've had, or challenges that you've had with that workflow, that I think this goes a long way to addressing. So what I'm going to be talking to you about is the Scriptable Tools framework. The Scriptable Tools framework inside of Unreal is pretty much brand new. It came out with 5.2 as an experimental feature. And what the Scriptable Tools framework allows you to do is it allows you to create your own custom editor modes. It allows you to draw heads-up displays, sort of get the position of the mouse and the viewport, brush strokes and things like that, and then use that to provide the inputs for tools. And then additionally, you can create customized parameter interfaces just like you could with the editor utility widgets. So the question that I had on my mind when I saw this new feature was, and how can I use it to make my tools inside of Houdini better that I want to use inside of Unreal? That question and a bit of exploration around the subject took me to the Houdini Engine Public API. And what this allows you to do inside of Unreal is to create Houdini sessions, to instantiate digital assets, manage their lifetimes, and to change the parameters and sort of automatically cook or control the cooking process of these digital assets programmatically via blueprints. So this is an amazing interface to work with Houdini inside of Unreal, and it really allows you to create tools that are a lot more involved and well thought through, and creating a better user experience for the artist that's going to be using it. So I'm going to jump into Unreal now and show you a scene. This is an update to Project Pegasus, or at least it's a version of Project Pegasus, where everything that you see has been created with digital assets. But those digital assets have been created or have had their lifetimes managed by an editor mode that's been created with this new Scriptable Tools framework. So that's the interface that we're looking at right now. You can see a list of the tools that I've already created up here on the left, and I'm currently inside of one of those tools, and that tool is the path tool here, and we can see the parameters that I've decided to create and expose to the end user. So all of these rivers and all of these landscape splines and all the vegetation that's been spawned here has been handled by Houdini Engine, but actually everything is customizable now inside of Unreal, and we have control points for all of these splines, so we can sort of have a really nice mix between a manual and a procedural workflow. And I'm going to show you what that looks like. With the tool active, if I shift left click, I'm going to see that Houdini starts cooking, but because it's a single point, it's not going to do anything other than create a gizmo right now. But the second time that I shift click now, I'm going to see that Houdini is going to think for 1 second. It's really quick, and it's going to generate this new path on the terrain. And if I shift click once more, wait for it to finish cooking, we're going to see that we have the ability to, in a really nice way, without having to worry about the lifetime of the Houdini digital assets or anything like that, we have the ability to define a curve and to then retrieve, sort of send that information over to Houdini, and then Houdini is going to do a pathfinding algorithm on the terrain, and this is going to be sent back to Unreal and used to determine the position of the curve. And I can cancel my work on this curve just by control clicking somewhere else, and now that's been saved into the level, and go somewhere else, and I can say, okay, well, I want to start drawing a new curve, so I'm going to shift click, and I'm going to go shift click way off into the distance there. It's going to take a little bit longer to cook this, but hey, that's not too bad. It's now generated a new path, which is going to conform in sort of a nice way to the terrain, And if I wanted to, I could even go and tweak other parameters like avoid work, for example. And then if I just cause this to update by giving it a little wiggle, we're going to see that we now get a completely different path generated where the spline is trying to avoid taking the steepest route up the hills. So if you've not already seen the part of my previous video where I was going into how did we set up this pathfinding algorithm, I highly recommend you go and check that out. And in this video, we're going to be taking a look into how these kinds of tools work, how we can get the communication between Houdini and Unreal Engine working. And we're going to go through a series of increasingly advanced examples showing how we can really use these tools effectively together. The tools framework and the Houdini Engine Public API. We're going to begin with a couple of simpler examples. But before we do so, we need to just go ahead and make sure that we have all of the necessary plugins enabled. So we need to make sure that we're going to enable the Scriptable Tools editor mode and the Scriptable Tools framework. We're also going to make sure that we turn on the water plugin, and we're going to make sure that we have landmass, PCG, and geometry script. And these last two, or in fact, these last few aren't absolutely necessary, but each of them comes with a helpful library of blueprint functions that relate to processing curves, landscapes, and geometry, which is why we're going to enable them so that we have the ability to discover all sorts of interesting functions that might be useful to us in our Scriptable Tools journey. Now that we've enabled the plugins, we're going to go ahead and create our first Scriptable tool. So inside of an empty directory, inside of your content folder, we're going to go ahead and create a new blueprint class of type Scriptable tool. And we're going to create a tool of type editor Scriptable single click tool. So this is effectively the most simple form of interaction you can have with a viewport. If you click somewhere in the viewport, then we can read the position of that click, shoot a ray into the world, and retrieve information about what is under the cursor. So I'm going to call this tool basic example. And we're not going to see it pop up immediately inside of the Scriptable Tools mode list of tools. And that's because we need to go and assign a unique name to this tool. So opening up the tool, we're going to see that the class defaults panel is open, and we have the opportunity to define the name of the tool. So I'm going to call this basic tool, and the long name is going to be the same. And I'm going to set the category to be workshop. Okay, so we've created our first tool, and we still don't see it pop up here. So what we need to do now is just go and switch off of the Scriptable Tools mode, turn it back on. We'll now see that our tool is ready and waiting to be used. So we've got our tool, but right now it doesn't do anything. If I activate it, we don't see any parameters, and if we click in the scene, nothing's going to happen. So let's set about creating some really simple behavior just to be able to tell if the tool is even active when it says that it's active. Inside of the basic example, we're going to go to the functions, and we're going to override the function onScriptTick. So this means that as long as the tool is active, every frame we're going to do a thing. And the thing that we're going to do here is we're going to print a string saying hello. So let's go and compile and save, and then activate our tool. And what we'll notice is that we don't get any print string into the screen. And why is that? Well, it's just because the tooling doesn't print to the screen when it's a Scriptable tool. You have to go and check the log. So there we go. If I clear the log, we can now see that indeed it is printing hello every tick. But if I complete the tool, it's going to stop printing hello. So we can see that the lifetime of the tool was valid. It was set up and working. Okay, so we can go ahead and get rid of that print string since it's not going to be needed. But let's go and have a look at the other functions that we can override. We've got onGizmo transform changed. So we're not going to talk about gizmos yet, but we'll get to that in a minute. We have some other functions relating to being hit by a click or tested hit by click. These are interesting, but we'll get back to those in a bit too. And we've got some hover related functions, which we'll largely be ignoring. And then down here at the bottom, we can see that we've got onScript draw HUD, onScript render, and onScript setup and shutdown. So these four are very important, and I'm going to dive into what each of these does right now. So the first function I'm going to override after the tick is the setup. And what this function does is, if we mouse over it, it gives you a little tooltip. But basically, the minute we start running the script or the mode, it's going to run some sort of initialization logic, which can be determined by you, the user, or the tool creator. We've also got onScript shutdown, and this is going to determine what happens when we exit the tool. So one thing to bear in mind with the Scriptable Tools mode is that if you add actors to the world using the tool, then you may be wanting to keep track and manage the lifetimes of certain actors so that they only exist so long as the tool is active. And what this shutdown here allows you to do is to terminate the lives, destroy the actors that you no longer want to exist once you exit the tool. An example might be a sphere around the cursor showing you how large your brush is if you were doing some kind of painting related workflow. Okay, and then the last two we have are onScript draw HUD and we have onScript render. So these two are really interesting, really cool. These allow us to draw sort of text onto the screen at desired locations, which is really useful to create a better UX for your tool users. And also we have the ability to render sort of temporary geometry. And if you're rendering that geometry out of this onScript render function, and by the way, both of these functions behave a little bit like our onScript tick. So they're going to happen every frame that the tool is alive. But the nice thing about these two is that they give you access through these little connection pins here to draw things on the screen that are only going to be tied to the lifetime of the tool and won't exist beyond that. So this can be really nice stuff to play with a little bit later on. Okay, so this is the kind of core signals, I suppose, that we have from the tool, from the script itself. And then the last one, which is crucial to add to the scene, is on hit by click, because we want our tool to respond to when we interact with the scene. And this is where we're going to begin. Okay, so we're going to want to grab when we click the screen, we're going to want to do something. But let's just verify that we can even see, just like we did previously with the tick, we can even see that the signal is being received when we click in the scene. So I'm going to go ahead and enable my tool mode. I'm going to make sure that I'm previewing my output log, and then I'm just going to click once. And now we can see every time I hit hello, I hit somewhere on the screen, I click somewhere, we get this hello message. And we also get a warning which tells us that default test hit by click implementation always consumes a hit. What does this mean? Well, it means that we haven't been super hygienic in how we've set up our hit detection. And there's another function here called test if hit by click that we need to put some logic into to tidy that up and avoid seeing that warning. But that's something that you can look into if you just read the documentation. And for the purposes of this tutorial, we're going to ignore it. So we know that when we click, the Unreal Engine is able to see that. And off of the hit by click event, we can see that we've got this click position structure and we've got this modifier structure. So we're going to go ahead and break the click position structure to begin with. We can see what it contains, and we can see that it contains world ray, has 2D and screen position. The one that I'm interested in right now is world ray, and I'm going to right click that and split that struct pin. So we can see that we get a world ray origin and a world ray hit direction. So this is basically, according to where you are currently in the world and where you've clicked on the screen, what is the world space position and direction of your click? We can use this to do a line trace by channel. And we're using by channel because we have the ability later on to define custom channels if we needed to. For the time being, visibility will be fine. It will trace against anything that we can see in the world and return true if it hits something. But if you wanted to develop a tool later on with a bit more advanced functionality, you can define your own custom visibility channels in the project settings, such as landscape, for example, and then you can make sure that your traces are only hitting the landscape. We're going to wire the execution pin into the line trace by channel, and now we just need to calculate the end position. We already have the start position, so we can wire world ray origin in directly to that. And we're just going to add to this origin the direction, but multiplied by some factor. And that factor is going to be a simple scale, a one-dimensional scale. So we're going to search make literal float, and we're going to set this to be a really, really long distance. Okay, so we're creating our line trace. And in order to see whether that's working, we're going to turn the draw debug type to duration, I'm going to draw that for 1 second. Now I'm going to go ahead, compile and save our tool, run the tool once more, and now we should see that as we click in the scene, we're creating a ray, and when it hits the landscape, in this case, we can see underneath the landscape it goes green. That means that it did correctly read that it hit the landscape. You can see that as well. That's a slightly easier way to see it. Okay, so we're hitting the landscape, and we can see that we're getting the correct location. And we want to do something with that location of that hit. So we can see that on the line trace by channel, we have this out hit. So we're going to break that hit result. And we can see there's a ton of stuff here. And the only one that we're currently interested in is the location. And honestly, this is something we find ourselves wanting to retrieve from a line trace pretty often. So I'm just going to go ahead and collapse that down to a function, which I'm going to make pure. And I'm going to name that get hit location. That's a little bit neater. Now that we have the location, we want to do something at that location. So right now, for this basic example, what I'm going to do is I'm going to spawn an actor from class. Now, I actually was a little bit hasty there, and just to illustrate what I did wrong, I'm going to search once again for spawn actor from class. And we can see that we have two versions of this function, one which is under the heading game and one which is under the heading level utility. And we need to select the option that is under the heading level utility. Okay. Going to tie that up to our execution pin. We're going to wire the location in. And then for the actor class, for the time being, I'm just going to pick static mesh. And I'm going to make sure that I set the static mesh to a static mesh, otherwise it doesn't have a static mesh assigned to it. We're going to pick, why not, 1 meter cube. And now we can see that if I enter my tool once more, and start to click around in the scene, I'll just go a little bit closer, you can now see that indeed we are able to spawn these cubes nice and automatically. Okay, so that's an introduction to how do we sort of interact with the scene in Unreal using the Scriptable Tools framework. One thing to bear in mind is that the way that we've currently set it up, it is just going to spawn an individual actor for everything that we're spawning into the world, and there's no cleanup happening, so these are going to live beyond the lifetime of the tool. And I just realized I didn't actually explain how we leave the tool, but we need to click this complete button down here. So we can enter the tool by clicking the tool itself, and then we can go and hit complete. I think we can also hit escape on the keyboard. Yes, either of those work. And you can see that when we leave the tool, it doesn't tidy up these meshes after the fact. So we would need to manage the groupings, the sublevels, and whether we even wanted them to continue to exist ourselves. And we would need to define all of that inside of our tool. Okay, so we've created our first basic example. But one thing that's clearly missing is that there's currently no parameters that allow us to sort of manipulate what is being spawned, any other properties of what's being spawned, like size, rotation, and all of that kind of thing. So we need to set up and define these parameters. So let's go ahead and have a look at how that's done. I'm going to jump inside of the tool once more. And instead of just hard coding the static mesh that we want to use, I'm going to go ahead and right click the mesh. I'm going to promote it. And this isn't going to work, but I'm going to walk you through what would be kind of a logical thing to try if you were just trying this for the first time. So I'm going to name this mesh selection, and we're going to make this editable. And if this behaved like a typical blueprint, then we would expect to see this exposed on the tool. But if I activate the tool, we don't see anything up here. We don't see any parameters. And this is totally expected. But why? Well, it's because in the Scriptable Tools framework, we don't define the parameters that the user sees inside of the tool itself. Instead, parameter sets or property sets are modular components. So you can define them separately to your tools, and that allows tools to share property sets between them, which is really useful if you're starting to build up a library of tools with some shared functionality between them. So how do we create this property set, and then how do we attach it to the tool so that it becomes exposed through this panel? Well, we need to go back to the Blueprint Creation tab, and we're going to go ahead and search for property sets. And we want to create an editor scriptable interactive tool property set. Okay, so we're going to go OK. We're going to go ahead and create that, and I'm going to call this property set basic example. And now, just like we did previously in the tool where we created this mesh selection parameter and made it instance editable. In fact, let's go ahead and delete that now. We're not going to use the parameter in the tool itself. We're going to open our property set and we're going to create the variable in here instead. We're going to make sure that this variable is set to static mesh of type static mesh. And we're going to make this, we're going to name this mesh quite simply. Finally, we need to make this public, compile and save the property set and go back to the tool. Now that we're in the tool, we need to attach the property set to the tool. And the way that we can do that is if we go to the onScript setup event, we can go and add a property set, and the type needs to be set to the basic example type that we just created. I'm going to leave the name as settings for now, that's fine. This becomes more important if you have multiple property sets at the same time. And one thing to note here is that this isn't coming out as being of the type that we set it to be through this class selection panel. So what does that mean? Well, it means that we actually need to go ahead and cast it to the property set basic example. So this basically means that we now, by dragging out of this blue pin here, have access to the variables that are defined on the property set. So we called that mesh. And if I search mesh, we can see that we can now get mesh from it. Whereas if we drag out from the new property set and search get mesh, we don't get anything. Okay. So now that we have added the property set to this tool and we've cast it to the correct type, we're going to go ahead and promote that to a variable inside of the tool itself. And the reason we're doing that is so that we can then anywhere inside of the tool, anywhere inside of the logic, we can go ahead and grab variables from it. So in this case, we want to go ahead and grab the mesh. Okay, so now let's go and check that that's worked. Let's run the tool once more, and we can indeed see that we have the ability to select the mesh here via this parameter. And I'm going to go ahead and select a different mesh. Let's go with the cone. And now we're going to click and spawn that in the scene. Okay, so we've defined our parameters, and we could go ahead and add scale, rotation, and any number of other things here. But I think that will do for the purely Unreal portion of the Scriptable Tools framework. So the next thing we're going to do is going to look at the Houdini Engine Public API inside of Blueprints, and we're going to have we're going to explore how we can control Houdini through the Scriptable Tools framework, and how we can instantiate HDAs, create Houdini sessions, and basically unleash the full raw power of Houdini directly inside of Unreal. So we're going to go ahead and create a new tool. We're going to go to Blueprint class. We're going to search for Scriptable Tool. We're going to once again create a single click tool. I'm going to call this tool Houdini example, and we're going to jump inside. Okay, so once again, we're presented with a blank interface. Inside of this node view, we're going to create the functions that we're certain that we're going to need at some point or another. On script shutdown, and where's the functions? There they are, and probably on hit by click as well. Okay, so these are kind of the most important ones for the time being. So let's go ahead and just search Houdini to see what comes up. And out of the bat, there's quite a lot of options here, but it's just this one underneath the first Houdini Engine dropdown that we're most interested in. This gets us access to the Houdini Engine Public API and all of its functionality. And what we can do here is we just start to explore. Let's have a little look. Let's search for HDA, and straight away we can see that there's something called process HDA which comes up, and you could read all of this text. I'm not going to. I'll explain what this does in a minute. Let's have a little look as well at session, and we can see we have a bunch of parameters relating to session, stop session, and restart. And let's have a little look. Imagine we have our HDA. What if we wanted to go ahead and recook it? Well, we can't. So why is that? Well, that's because in order to process a specific digital asset, we need to be dealing with that asset. So we basically need to be dragging out of this object reference here instead, the asset wrapper. So asset wrapper is a concept that's important to consider when you're working with the Houdini Engine Public API inside of Blueprints. And basically an asset wrapper is Houdini Engine's kind of representation or understanding of a digital asset that's in your scene. It's quite different to the digital asset that lives in your world, because this is a Houdini asset actor. And the Houdini asset actor, which lives in your outliner in Unreal, is not the same thing as the asset wrapper that's created when you instantiate an HDA. Okay, that probably doesn't make a huge amount of sense right now, but it will start to maybe make more sense as we continue with this example. So let's go into the process HDA and drill down a little bit. We can see that we have the ability to define an HDA that we want to create, and we can set the location and set some parameters and inputs. And then we have a bunch of execution pins that come out after the HDA has, a bunch of execution pins that come out once various processes that the HDA is doing have completed. So in a way, we can think of this process HDA as a kind of black box node that does the whole job of instantiating a digital asset, setting its inputs, and then cooking it. And it gives us the ability to define what happens after stages of that cook process have completed. This is handy, and it's a nice way to deal with digital assets if you know that you just want to kind of fire and forget them. But I think one of the major strengths of working with digital assets programmatically is having the ability to define when they're created and when they cook, and being able to control that very manually. So after a little bit more rooting around, I discovered that we have another option, which is its instantiate asset. Okay, so these two things are somewhat similar, but the process HDA does a lot more, whereas the instantiate asset only deals with the instantiation. And then if we want to set things like parameters, node inputs, and so on, we do that in a kind of more typical way that we might approach setting parameters on objects inside of Unreal. So let's use the instantiate asset. Let's use the instantiate asset function instead of the process HDA. And we'll just leave all of this here for the time being, but move it somewhere out of the way. And let's define the asset that we want to instantiate. Let's have a little look at the options we have available to us. And if you've got the Houdini Engine plugin installed, which you will need to in order to see these functions existing, then we can have a little look through and we'll be able to find that there is a node called BGO import, I think. Let's have a little look. Houdini BGO import, and this is provided with Houdini Engine by default. So this asset can basically target a BGO on disk, and it will just load it into the Unreal Engine scene. Okay, so we've got our BGO import digital asset that's going to be instantiated at some point, but we haven't decided when. And we're just going to make sure that we turn off enable auto cook. Everything else can be left on its default settings for the time being. Now, do we want to instantiate the asset when the script sets up, or due to some other input? Well, we can decide that later. For the time being, we're going to just define a new custom event called instantiate HDA. If I could spell correctly, that's what it would say anyway. And now this instantiate HDA, if I spelled it correctly, it would also be easier to find. Instantiate HDA, there we go. Go on, let's go and rename that so I don't cause more problems for myself. So now we have the ability to call this event whenever we like, and go on, why not? Let's just plug it into OnScript setup for the time being. But we do need to be careful, and I'll demonstrate why right now, actually. If I go ahead and compile and save this, you know what, I'm not going to demonstrate what can go wrong, because I found that it can cause quite a lot of instability and crashiness with Unreal and Houdini. So I'll explain it, and then if you go and do it in your own time and make the same mistake, you'll know why. So basically, what this instantiate asset is going to do is it's going to create the Houdini wrapper. That's what the object here is that's being returned. It's going to create that wrapper, but it's also going to add the Houdini asset actor to the scene. So that's going to happen when the tool runs currently. But when we exit the tool, just like previously when we spawned all of these meshes, we're going to leave these assets existing in the world. And what that means is that we're essentially going to be creating an increasing number of wrappers as well. So not just the asset actors, but also the wrappers. And most of the time, we're going to want to remove these once the tool has finished its process. That's one of the beauties of working with the Scriptable Tools framework, is that you can have a digital asset that only lives while the tool is active, creates its outputs and saves them into the scene, and then the digital asset itself disappears. And you might think, well, let's go ahead and promote this to a variable. And we'll call this the HDA wrapper. And then we can go ahead and wire the HDA wrapper into a destroy, but we can't. There's no ability to destroy the HDA wrapper. So you might start looking around and try and find the reference to the asset actor that's been created. Let's have a little look, see if we can find that coming out of here. Get Houdini asset actor. Okay, and then we may try to destroy the actor like this on script shutdown. And this is problematic because if we destroy the asset actor, but we don't deal with the wrapper itself, then we're only deleting the object in the scene. We're not actually sort of removing the digital asset wrapper or the sort of representation of the digital asset that Houdini Engine itself is dealing with. And as I said before, this can cause a lot of crashiness. So that's why I'm kind of going through this explanation. And the correct way to deal with the removal is to use instead, not this either, is to use delete instantiated asset, which is coming from the Houdini Public API asset wrapper. Okay. So now when the script sets up, we instantiate the HDA. When it shuts down, we're going to de-instantiate or delete the HDA. So let's go and see if this is working. I'm going to go ahead and run the tool. Can we see anything being created? Well, no. And that's because I have not followed my own advice and I made a mistake. And the mistake that I made is I created a new tool called Houdini Example, but I didn't follow my own advice and I didn't go and give it a new name. So we need to open the tool up, go to class defaults, and we need to set a new name for this tool. So I'm going to call it Houdini Example, and I'm going to put it in the same category as the basic tool. Now we're going to close and refresh this modes panel, and now we can see that indeed, when I run the tool, I just clicked on it over here, we can see that we're also in the mode down here. You can see that it created the Houdini BGO import asset actor. And now if I complete the mode or exit the mode, it's going to remove the HDA asset actor from the scene. So it's a nice and tidy way to work. All right, now there's one other thing that I glossed over that I should have covered, which is the fact that we haven't yet dealt with how sessions are managed or how the Houdini engine is being managed. Houdini engine session is being managed by the tool. When we drag a Houdini asset actor into the scene, often or normally the Houdini engine, if it's set up correctly, will pop up with a little message saying creating session. It will run for a moment and then you'll be able to see that that Houdini has indeed got an active session running. So if we want to manually control this via the tool, then we also need to reuse those functions that we found earlier. We need to use those functions we discovered earlier. So we're going to go ahead and create, before we do anything with the HDA itself, we're going to go ahead and make sure that we've created a session. But if a session already exists, we don't want to be creating or trying to create a new session. So we're going to say, first of all, is session valid? And we're going to make this be on a branch. So we're going to make it conditional. And we're going to say, when the script starts, is the session valid? If the session is already valid, we'll just go straight away ahead and instantiate the HDA. And if it's invalid, then we'll create a new session. Okay. And at this point, things are going to start getting a little bit messy. So it's probably a good idea to create some comments. So I'll say setup script, and I'll make that bubble pop up when we're zoomed out. I'll go with create HDA because instantiate is hard to spell correctly quickly. And then also shut down. Okay, great. So let's test it once more, even though nothing has technically changed. Or in fact, what we can do is we can stop the Houdini session. Okay, the session has now been cancelled. And now if we run the tool once more, we're going to see that there's a bit of a lag while it's setting up the Houdini session. And there you go. You can say Houdini Engine session is now connected, and it's created the BGO. So complete the scene and rerun the tool. Because the Houdini session already exists, it just went and created the Houdini asset actor immediately. Okay, so that's a pretty clean setup now, and that's all working as expected. So how do we go about providing the inputs to this digital asset that we have instantiated and cooking it? So the Houdini BGO import digital asset is really simple. It does what it says on the tin. If you have some geometry in BGO format that is on your disk somewhere, for example, a landscape or some meshes or instances or a set of landscape splines, then we can basically use this digital asset to target that object on disk, and then it's going to load it into Unreal and configure it all correctly according to the attributes that have been set on the geometry. So it's a nice thing to wrap up as a kind of first example of creating a tool inside of the Scriptable Tools framework inside of Unreal with Houdini. And we're going to want to be able to recook it or cook it. So we're going to go and drag out of the wrapper and look for cook functions. We can see there's quite a few, but the one that's most interesting is just quite simply recook. I don't want to cook it immediately after instantiation, so I'm going to grab a reference to the wrapper. So I'm just dragging that out there and hitting get. And just like we did with the instantiate HDA event, we're going to create a new custom event called cook. There we go, nice and simply. And we're also going to go ahead and put a comment around this to try and be a little bit organized while we work. Okay. All right. So this is how we're going to call the cook. And one option is to make the HDA cook when we click in the scene, which maybe makes sense if you want to spawn something at a particular location in the world, or you want to deal with something, a specific object, and you want to get the object that's been hit by your click, return it, set it as a parameter on the HDA as an input, and do something with it. But we're not going to worry about on hit by click with this example. Basically, we're going to be looking for a signal that we're going to send manually via a button on the tool, so a parameter. And just because I had a little lag spike there, I'm going to go ahead and save. I encourage you all to do the same. All right, so we're going to go, and what we need to do, the steps that we're going to follow next are we're going to set up a property set. So just like we did on the basic example, we're going to define a property set. We're going to add that property set, which is going to be of a different type. So this was the property set type that we created for the basic example. So I'm going to go and close those down. We're going to create a new property set, which we're going to attach to this tool on script setup. So let's make some space for it there. And we can even go and add the property set now. So we're going to add this function. We're not going to select the property set type yet, but it's ready and waiting for once that's been created. So we're going to go ahead, create that property set, add it to this tool, and then we're going to create a button on the tool that says import BGO or something to that effect. And when we do that, it's going to fire off this recook sequence, which is going to load the object through the digital asset. So it's going to cook the digital asset. Okay. And in order to pass the input that we've provided via the property set to the Houdini digital asset, we're going to have to look at how the Houdini Engine Public API inside of Blueprints deals with setting parameters and inputs. So to begin with, let's go back and we'll create a new property set. So we're going to create a Blueprint class. We're going to create a property set, and it's going to be an editor scriptable interactive tool property set. And this property set is going to be called, quite simply, BGO. We're going to add a new variable here, and this variable is going to be of type file path. And then we're going to call this file, why not? Don't forget to make it public. Save the property set. We're going to return to the Houdini example tool. And then we're going to go back to the start of event on script setup. And I'm just going to control click and drag on that wire to connect it up here. And if the property set was successfully added, we'll continue with the rest of the tool setup. Now we're going to make sure that on the property set type, we pick BGO. and we're going to promote that. Almost caught myself out there again. Remember, we need to cast it first. So we're going to cast to the property set BGO, control click and drag the wire and promote that to a variable as property set BGO. That will do. So we're now adding property set to tool. And because that's part of the setup script, I'm going to expand this here. Okay, great. Compile and save. Let's go and verify that the file picker exists. So we'll run the tool, and now we can see indeed there's a parameter called file. And if we click the three little dots, we can go ahead and pick any file that we choose on disk. Great, but it's not currently hooked into the digital asset. So we once again go inside of our scriptable tool, and then we're going to think about where we want to pass that information through to the tool. And we could go ahead and do that here after the cook process. And this may well turn out to be the most appropriate place to set the parameters right before the cook. But we also have the ability to, much like with the process HDA blueprint here or function, we have the ability to grab sort of specific events that happen with the lifetime of the digital asset. So we have pre-instantiation and post-instantiation. So this means before the object's been created, and this means just afterwards, as well as post-cook and pre-process and all of these other options. So we could, if we have parameters that we know that are going to be defined immediately when the tool is created, the logical place to set them would be in either pre or post instantiation, which is basically just before or after the digital asset has been created. Doing it on post cook is going to be useless because that would be setting the parameters after the cook has already happened. We can think of post instantiation as potentially pre-cook as well. So how do we do that when we've instantiated the asset via this function instead of using the process HDA? Well, what we can do is we can bind to, and then if we have a look through all of the bind options, we can see that we have access to all of those functions or execution pins. And the one that we often would want to find ourselves using is either the pre or post instantiation. So let's go ahead and do the post instantiation. Okay. I'm going to add a custom event like so, and then post instantiate. There we go. Okay, so basically now this event will fire right after this asset has been instantiated. And this is useful because it means that if you want to or need to sequence the creation of multiple digital assets and you don't want Houdini to get locked up, Unreal to get locked up trying to do too much at once, you can wait until the first actor has been instantiated. You could have a delay until next tick or some other defined period, and then you could begin to instantiate and deal with other digital assets too. So you can start sequencing your digital assets like so. I'm just going to, additionally, I'm going to pull out of HDA wrapper and click R on my keyboard to create a reroute pin. I'm going to do the same once more. And actually it only needs to be connected up once, so I'm just going to empty that. I'm also going to bind an event to on post cook, because this allows us to fire off a signal whenever the cook has finished. And we're not going to be using that right now, although we could do something with it. But this is useful if you want one digital asset to fire off using the outputs of a previous digital asset as the input, or if you want to pass information from your cooked digital asset to, say, a blueprint inside of Unreal. So this allows you to say, wait until this thing has finished cooking and then do something else. So these are pretty useful to know about, but we're not going to actually use these right now. Okay, so we know these exist. We know that we can sequence things down here, but because we're doing this all in blueprints and we have a lot of control over the timing of when things happen anyway, what we're going to do is we're going to say that the parameters are going to be set just in time before the recook happens, which will always guarantee that we have the correct parameters when the cook is taking place. All right. So basically, we just want to pass a file path to the digital asset. But to do that, we're going to need to go and check what the name of that parameter is on the digital asset. So I'm going to go to the plugins folder and I'm going to search for, I'm going to filter by type. I'm going to go to miscellaneous Houdini asset. Okay. So we're going to filter by type Houdini asset. I'm going to go and find the Houdini BGO import node, and I'm going to instantiate that. Okay. So now that it's instantiated, I'm going to scroll down through the parameters, and this is a great example of why the Scriptable Tools is such a boon for artists creating tools. And just look at how cluttered this parameter interface is, and how cramped, and how many things that don't even relate to the tool that we've created or want to use. So this is alone enough of a reason to want to make your tools run through the Scriptable Tools framework. Anyway, rant over. We can see that the parameter is called file, just under all lowercase file. The name geometry file in capitals is the label, and the actual name of the parameter is file, all lowercase. So, okay, now that we know that, we can delete the digital asset from the scene once more. And I'm going to go back to content. I'm going to find my tool that I was working on. There it is. And we're going to open this up. So we know that we're looking to set a parameter that is simply called file, all lowercase. So we're going to get a reference to the wrapper, and let's just drag out of here and search for parameter. We can see that there's quite a few options. So let's narrow that down with set parameter. And we can see still there's quite a few options. So let's see if we can set a string parameter, and there we go. Nice and simply, we have the ability to set a string parameter on the digital asset. Now, my understanding is, and I may be wrong about this, but my understanding is that every parameter that is provided to the HDA from the Houdini Engine Public API is considered a tuple. So what that means is essentially, even if it's a single string on the digital asset, it's technically considered by the Houdini Engine Public API as an array of strings. And we always have to define the index that we want to be setting. I don't know why this choice was taken. Potentially it simplified the development of the public API blueprint kind of scripting tools. But what that means is when we're setting a single string, like we're trying to do here, we can leave the in at index on 0, and we can just set the value. If we were setting, for example, a vector parameter, we would actually set a float parameter value like so, and we would need to, for the X channel, leave the index at 0, the Y channel set the index to 1, and the Z channel set the index to 2. And this is the same as setting a vector. And if it's an array, you would just keep adding the indices like so. Okay, all right. So we're going to be setting a string parameter value, and the string parameter value that we want to set is simply called file. And then we want to pass the path from the tool parameters into the in value here. So we're going to get the property set BGO, and we're going to set, we're going to get the file. Now we can see that the type of the file isn't the same as the in value, but that's fine. What we can do is we can just go ahead and split that struct pin, and it's going to break it down to a string. Okay, so this should now be working, and whenever we cook the asset, it's going to set that file path, and then it's going to recook it. But we just want to test if this is working to begin with. So what we're going to do is we're going to disconnect the cook. That means the digital asset is not going to cook. We're only going to be setting the string value, which means we now need to define when this cook event gets called. And to do that, I want to add, if I press Shift 9 to open the Scriptable Tools mode, and then I go to the Houdini tool, it means we're going to want to add a button on the parameter interface, which is called reload or something to that effect. Or update paths, maybe. Okay, so we're going to go to our property set BGO, and we're not going to add a variable. What we're going to do is we're going to add another custom event, this time inside of the property set, and we're going to call this, let's call it recook, actually. Yeah. And I'm going to say that this can be called in editor. That's very important. All right, so now we've created a custom event which will be visible on our tool, but we also need to be able to pass the execution of the recook event through to the tool. The way that we can do that, one way that we can do that is we can create an event dispatcher. I'm going to call this recook dispatch. I'm going to drag that in here. I'm going to call it. And this now is a signal that can be listened for inside of the tool to say when we want to do something inside of the tool. Okay, So we're going to go back to the tool Houdini example. And actually, technically, what we're doing is with this event dispatcher here, this logic, is we're allowing ourselves to do very similar thing to what we did when we said on post instantiation and on post cook. That basically, we're listening for a signal that's coming from somewhere else, and then we can create an event inside of the tool itself. Okay, so we're going to go back to where the property set is created or added to the tool, and we're going to add a new section in between the creation of the property set and the instantiation of the HDA. And that section is going to allow us to listen for the whenever this recook event is fired. So we're going to drag out of the property set BGO pin. We're going to search for bind, and then we'll be able to see that we have bind event to recook dispatch. Okay, so now, just like before, we pull off the red pin, we add a custom event, and we're going to say received cook signal. Okay, now this event is going to call the actual cook event, like so. And now we should have all of the logic that we need set up. I'm just going to set this group to be called listen to events on property set. Pretty bad name, bit of a mouthful, it'll do for now. Okay, so let's have a little refresher before we go and actually test this out. We are on script setup, creating a new property set of type BGO. We're listening to the property set to see if it has any cook events being fired. And if we do, we're going to cook the HDA. And this doesn't actually tell the thing to cook, to be clear. This is basically just setting up the listen for the signal. So it doesn't matter, especially, that this is happening before the instantiation of the HDA. After that's happened, we're going to check to see if the Houdini Engine Public API session is already valid. If it is, we'll instantiate the HDA. And if it's not, we'll create it and then instantiate the HDA. So when we instantiate the HDA, we're selecting the type of HDA we want to instantiate. We're promoting it to a variable so that we can access the properties and modify them anywhere inside of the blueprint. And we're listening. We've set up the listen for when the HDA performs certain tasks or finishes completing certain tasks. So we're listening, but we're not actually doing anything with those signals right now. Finally, we're listening for we're listening for the cook event. And when we receive the cook event, this function is going to be fired. We grab the HDA wrapper and we set the file parameter, the parameter called file, which is of type string, and we're grabbing that value from the property set, which we'll be able to fill out when the tool is active. We're marking that as changed. And if this is all working, when I hit the cook event, I would expect that if I select the HDA in the world, we'll be able to go and have a look at the properties of the HDA and see that that path has changed. All right, so let's test it out. We're going to run the Houdini asset. We can see we've already actually got the Houdini BGO selected. We can see that the geometry file is currently empty. If I now go up to the parameters of the Scriptable tool and search for a file, I need to go and find a BGO. And this is where my planning was maybe subpar because I'm not sure that I actually have a BGO. So let's go ahead and quickly make a little BGO. And the BGO that I'm going to create is going to be a simple curve. Okay, so I'm going to draw a curve like so. Or actually, that's a terrible idea because a curve is not going to show up unless we do some additional stuff with it. So let's just do a box. There we go. It's a very big box. I'm going to go and save it out. File cache, that works. And it's not going to be time dependent. It's going to be an explicit path. And I'm just going to save this to my desktop. Test bgo.bgo. Okay. I'm going to save it out. And then back inside of Unreal, I'm still in the file picker, so I can go to my desktop and I can go ahead and pick the test BGO file that I mentioned. Okay, so we can see that it's now filled out this file path here. And that still hasn't updated down here, and that's just because I need to go hit recook. And now we can see that when I hit recook, it has indeed set the parameter on the digital asset. Okay, so we know that that's working. And if I go ahead and complete the tool or exit the tool, it's going to delete the digital asset, clean up the digital asset from the scene. All right, so if we now go ahead and actually connect up the recook event, compile and save once more, run the tool, pick the file, and then hit recook. Created, it's all gone shady, and that's because it's created an absolutely enormous cube. Yeah, I forgot about the size I set was probably slightly ridiculous, but we can indeed see that's working. And now I go ahead and close the tool. It's going to remove that. So that's a very basic example, but it already, I think, hopefully demonstrates the power of connecting up your the Houdini Engine Public API with Scriptable Tools. Now we're going to move on to a slightly more advanced example showing a more kind of production-oriented use case. So we're going to go ahead and create a new tool. We're going to go search for Scriptable Tools. Single click as before. And we're going to create ourselves a scatter region tool. Okay, so this time, the way we're going to think about it is we're going to start by defining a region with a series of mouse clicks, which is going to be then sent to Houdini to perform some kind of scatter operation within that bounding region that we've created. So first thing we're going to look for is the Houdini Engine Public API, and we're going to go ahead and assume that we're going to want to create a session if one hasn't been created already. I'm going to say is session valid, and if it's not valid, we'll create the session. We'll overwrite the onScript setup function, and then we will wire this up like so. Okay, we can collapse this to a function called create or who create session. Okay. Next thing we're going to want to think about is how do we create the asset or instantiate an asset. So let's have a little look for the asset that we want to instantiate. And we're going to go ahead and select one of the stock Houdini digital assets that's already inside of the Houdini Engine plugin content. The one we want is the Houdini Engine Surface instancer. We want to disable auto cook as before, and we're going to want to make sure to promote this to a variable HDA scatter. There we go. Okay, we want to be able to receive a signal that tells us to instantiate the asset. So we've created a custom event called Instantiate. And on script setup, we're going to wait for the session to be completed. We're going to instantiate the asset like so. Going to create a comment box around the instantiation sequence and another one around the setup sequence. Okay. So the next thing we're going to want to be thinking about is how do we define the inputs for this HDA scatter tool? The output of the HDA scatter tool is simply going to be a set of objects that are scattered onto a surface of another object. So we're going to be able to want to select the object that is being scattered on and the object that is being scattered. And since I cannot remember the names of the parameters that will need to be set, I'm going to quickly go and find the digital asset in the content browser like so, and I'm going to instantiate it at the origin. Now that I've instantiated the asset, we can see that the parameter list includes parameters like instance mode, some transformations, some relax options, and options about the orientation of the object. The ones that I'm most concerned with at the moment are the Houdini inputs. Okay, so we can see that there's two inputs here at the moment called surface and instance. So if I just mouse over those, yep, they're just called surface and instance. Mousing over does nothing. So we know that we have two inputs, and the first input is the 0th input, or the first input is the surface to be scattered on, and the second input is going to be the instances to be scattered. Okay, so let's look at how we can set up inputs to an HDA. Inputs are handled slightly differently to parameters. I'm going to grab a reference to the HDA scatter, and I'm going to search for set input. We can see that we have set input parameters, set inputs at indices, but I just want to use set input at index, the most simple of them, and the one relating to the actual sort of object inputs to the digital asset. Now, straight away, I'm going to create my two inputs, and I'm going to create, in fact, rather than comment boxes this time, I'm just going to create a little comment tag saying instances, and I'm going to name this one surface so that I know what the two inputs represent. 0 is the surface to be scattered on, 1 is the instances to be scattered. Okay, so now we need to go about actually creating the input that's going to be provided. And this is going to require us to create an empty input of a certain type because Houdini digital assets can take different types of inputs, and then we're going to need to configure that correctly. So let's go ahead and look at how we can do this. I'm going to grab another reference to the HDA scatter, make a little bit more space. I'm going to create an empty input. Okay. And the input type that we want to create for the surface is going to be a world input. That means we can select an actor that exists in the scene to be scattered on. For the input at index 1, we're going to also create an empty input, but this one is going to be of type geometry. So we want to be able to make a geometry selection from the content browser, which might be a tree, a bush, or a rock, and that's going to be what is going to get scattered on the object in the world. Okay, now I'm going to deal with these one at a time from here on out. Because this is going to require us to get a little bit messy, I'm going to go ahead and create a function called create world, or who create world input. And I'm going to make sure that this has an output of type Houdini Public API input object reference. So I'm going to add a return pin to this, a return node to this function. And we're going to pull out this, this input object here into the return node to return that value. And I'm going to call this world input object. Okay. At the moment, we haven't said anything about what that world input object is. So we just need to pull out of that empty input, and we're going to set the input objects, which is going to be an array of objects that are going to be provided as input to the HDA. Now, because I don't like my wires crossing in this way, I'm just going to pull up and click R, R again, and down like that to tidy things up a little bit. I'm going to do the same thing now with the input objects array, and we're going to define that outside of the function with this array objects. Okay. Now, if we wire the Houdini create world input in here, like so, and then drag the world input object down like so, we set that up correctly. Now I'm just going to quickly check to see if I need to pull anything else outside of the array. I'm not a particular fan of the fact that I've hard-coded the HDA scatter as the HDA inside of the function. So I'm just going to remove that there and wire this in too and shift that up. Am I going to bother shifting it up? Yes, there we go. And I'll call that wrapper. So now it's a little bit more modular, a little bit more reusable, like so. Okay. So on the HDA scatter, we're creating a new empty input. We're setting the objects that make up that input, and then we're setting the input at a specified index. Now we just need to provide an array of objects, which we'll be handling through our property set. But before we do that, let's handle the geometry input over here. We're going to do the same thing and collapse this to a function. But before I do so, I can save a little bit of time by already wiring in the input like so, and also making sure that my HDA scatter is outside. And I'm just going to collapse this single function. We can see that it now has the blue pins created automatically. And this one is going to be called who create geo input. Okay. I'm going to reroute these wires a little bit to keep things as tidy as I can. And now I'm going to hop inside and make sure that these outputs and inputs have sensible names. Wrapper, geometry, input, object. And make sure this is indeed set to geometry. It is who geometry input object. And now we can do set input objects just as before. It's an array of objects. So this will be a selection of objects from the content browser. I'm going to wire this into the inputs so we can feed it in from outside. objects, like so. And again, I don't like how the wires are, so I'm just going to go ahead and reroute that, and that's looking nice and tidy. Okay, so we've got our geometry selection being set up. We've got our surface selection being set up. So we can wire these together and we can name this. In fact, we could probably collapse this even to a function. So let's go ahead and do that. And we'll call this function create, or who create inputs. There we go. So we're keeping things nice and organized. Great. So we're creating and setting our inputs on the HDA scatter. And let's just wire this up here like so. And we'll pull the HDA outside of that function too. And we'll pull the objects. And we'll pull these objects. And so now we need to just, again, wires can get so messy. This is one way in which visual scripting can be a bit of a mess. There we go. And we'll call the first array surfaces. And we'll call the second array instances. And just to be extra explicit, we'll call this function create scatter inputs. Good stuff. So we've got OnScript set up and we've got our instantiation. We've got the instantiation that's taking place and we need to decide when we're going to set up those inputs. So let's create a custom event called process inputs. Okay, and the reason I'm not just creating a cook event, although I will actually add that now too, is because I think that these two things, we may need to separate them out to provide a little bit of time between the creation of the inputs and the cooking in order to ensure that the inputs have correctly updated by the time we do our cook. Okay, so let's go ahead and actually, you know what? We'll deal with that if we come to it. We'll cross that bridge when we come to it. So we'll do a quick delay until next tick to try and prevent things from getting too congested. And then we'll grab a reference to our scatter, make sure that's wired in there. And I'll name that wrapper as well, because I forgot to do so. Do a little reroute like so. Do another reroute. And then we're going to do the recook. Okay. So that's creating our inputs and then doing the recook. And now we need to deal with what those inputs are actually going to be. So at this point, let's go and create a new property set. So I'm going to navigate to the correct place in my content browser. I'm going to create a property set, just of type editor scriptable interactive tool, property set basic scatter tool. Let's open this up. And I'm going to create two variables. And the first one is going to be of type actors. So it's going to be an actor, not actors, actor. So it's going to be actors in the world. And the second one is going to be of type static mesh. Just of type static mesh. So it's going to be a reference to a static mesh object in the content browser. We're going to make them both public. And we're also going to make them both arrays. We'll call this surfaces and we'll call this instances. Great. Now on setup, we're going to need to create the property set. So create property set, add property set, that's what I was looking for, of type basic scatter tool. I'm going to cast to basic scatter tool and we'll promote that to a variable as we did before. Then we are going to grab the references from the basic scatter tool, the variables. So we're going to get surfaces and we're going to get instances. Okay. And we're going to perform a little test, just as we did with the last example. We're going to see if we can change the inputs and see those inputs change on the digital asset before we do the recook. But before we go and test that out, we need to make sure that everything is set up correctly. And right now we're dealing with the instantiation and we've got a cook. We're not calling the cook, but it's there, but we're not dealing with the shutdown sequence. So we would have created a mess in our scene. So we need to make sure that we have the on shutdown, and we're going to grab once more a reference to our scatter. delete instantiated asset, like so. I'm going to call this shutdown. And now I'm going to just box this little up area and call it cook as well. Box this little area up and call it cook. And let's go and have a little look at the tool. What did I forget? Oh, we have a tool. It's a new custom tool that I haven't named. So that's one thing we should always do. Basic scatter category is going to be workshop for me. Go ahead and enter the tools mode. There is the basic scatter. We can now see our surfaces and our instances drop downs. And if we expand the first array of surfaces, we can see that that gives us the ability to pick something to scatter on top of, in this case being the landscape. And then the second one allows us to pick the object that we want to scatter. But the surface instance, you can see I already ended up in a bit of a mess because I've got these two instances. So I'm not even sure which one is the correct one. I think it's surface instancer 2. We can see that those inputs are not being updated. And that's just because we haven't defined when they should update. So I'm going to close the tool and I'm going to delete that sort of floating surface instancer, which shouldn't exist. We're going to go once more to our tool scatter region, and we need to define when the cook is supposed to happen, or at least when these inputs are supposed to be updated. So we go once more to our property set. We add a custom event called cook. We make it public. We create an event dispatcher, dispatch cook, call dispatch cook, back to the scatter tool, create a property set. So then we need to bind to dispatch cook as we did previously. And we're going to say, create a custom event, cook received. And then that's going to go ahead and try to cook. Now, before I actually test this out, I'm once more going to cast an eye over to make sure we're not actually doing the recook. So I don't want to blow up anything. Okay, save. We're going to run the tool. We're going to now modify these two. So we're going to select the landscape and we're going to select cube. And nothing's changing. Well, we just need to go ahead and hit cook. And now we're going to wait for a second. And there it's finished cooking. So we can see that indeed the landscape has been provided as the input to the digital asset, and the cube with socket has been provided as the geometry input. We're not seeing anything being scattered on the terrain because we have actually not fired off the cook event yet. And I'm not going to, because just spawning things naively across the whole terrain is likely to cause the computer to explode. I'm not sure how dense it is. It may be extremely dense. So instead, what we're going to do is we're going to terminate the tool. We're going to create a shape of type plane. We're going to expand that guy. Then I'm going to open the tool and rewire in the recook event. Save, run the tool. I'm going to select that plane and I'm going to pick the cube and then we're going to hit cook. And right now it's giving us some funny results. It's giving us 1 cube per vertex of the input geometry. And indeed, if we go and have a look at the parameters, we can see that the instance mode is 1 per vertex. And I think we want to use uniform surface scatter. So let's just check what the name of this parameter is. It is M instance mode. So let's go exit the tool, go and edit the tool, and we're going to need to define that parameter. So we can go ahead and set that parameter up prior to the inputs being set. So we're going to now set a, what was it? It was an int parameter value. And actually, let's go ahead and collapse this to a function. And we'll call this set palms, because we may want to set more than just the scatter density. We're going to make sure this is called wrapper again for clarity. Okay, and then on this guy, it was, I think, M instance mode, but we may have to go and double check that. and we just want to set the value. So the instance mode 0 was per vertex, and instance mode 1, that was the second option in the menu. 1 is uniform distribution. Okay, and let's just do return here. And what that means is that this is going to be blocking. So if we just call a function without creating the return node, it's going to sort of straight away try to go and execute the next bit of logic just automatically. Whereas if we wire the return out of the set in parameter value, out of the functions inside, then it's gonna try and run them after those have run. Okay. So Houdini set params, Houdini create scatter inputs, delay, and recook. Let's have a little look-see at what happens now. I'm going to go ahead and run the tool. I'm going to just double check the name was indeed correct. M instance mode. I think I spelled that all correctly. Now I'm going to hook up the plane, hook up the cube once more, and hit cook. And we now have cubes spawning. So let's go ahead and do the obvious thing. I'm just going to run that once more so I can check the parameter names. Let's do the obvious thing and try to increase the count. So uniform base surface scatter or attribute. Okay, so forced count is segs, I believe. So okay, I think we want to set a parameter called segs. Let's try it out. Houdini set params. I'm going to set segs. Let's try setting this to a value of 100. Make sure that we're wiring in the wrapper as always. Wrapper like foil wrapper. Pick it up. And there's the cube. And run the thing. And there we have it. So what we should really do to finish up this tool and call it a day is expose one more parameter to the user. Or in fact, we could expose any parameters we wanted to, but the parameter that I'm going to expose is the instance count, which I'm just going to call count. And then back in the scatter region, we can grab our property set and we can get count, which is an array. So we need to make sure it's single count. We're going to wire that in to the value. We'll make sure that our default value is set to something sensible like 100. And then if I run my basic tool once more, select the objects that I want to scatter, will be golden. And if I wanted to, I could of course exchange my trees for some of the trees that we have in the project. What are they called? Hazel? Yes, they are. Here we go. We'll go with 10 and we'll cook that instead. All right, these are all oriented the wrong way. So yes, it's not the best, but it will do for the purposes of this demo. And I think we can probably leave it there. Maybe I'll try turning it up to 30, see what happens there. There we go. All right, so thank you so much for watching. I've barely scratched the surface of what's possible with the Scriptable Tools framework and the Houdini Engine Public API. As mentioned right at the start, everything that we can see here is running using the Houdini Engine Public API with Scriptable Tools. All of the rivers and all of the roads can be moved around and interacted with live in Unreal and recooked using Houdini Engine on the fly, which creates beautiful synergy and really lovely artistic workflows. And I'm very excited and hoping to see lots more people using this workflow and pushing it to its limits. Thanks for watching, and I'll see you maybe at EPC.